Okay, 2012 AB number 1, we have a table of values giving the temperature of water in a tub. They tell you that the temperature is strictly increasing and twice differentiable. I would probably go ahead and make a note that W prime must be positive because they do tell you the temperature is strictly increasing. The only other piece of information in the paragraph that's kind of interesting that the table does not already tell you is that the water is actually heated for 30 minutes, and the table stops at 20 minutes. Okay, so question A, use the data in the table to estimate W prime of 12. And so W prime means the slope at 12. And the only way we can approximate that here is to find the slope from 9 to 15. So W prime of 12 would be approximately, and when you're estimating derivative values in this manner, you must write down the difference quotient, 67.9 minus 61.8 over 15 minus 9. Whoops, not 15.9, over 15 minus 9. Then you can go to your calculator and subtract that. That ends up being, what, 6.1 divided by 6. And if you want to throw that in a calculator, 6.1 divided by 6, you get 1.0166. And the only reason I did that, why I actually simplified it versus stopping with the difference quotient, which will be fine, is it does tell you to interpret the meaning in the context of the problem. And to answer that part, it helps to have a final numeric answer that makes a little bit of sense. So for this one, keep in mind that we did evaluate a derivative, and we found out that the derivative was a positive value. So my thought process is that W is increasing. So that's my thought process, even though they already told you that in the paragraph. But W is increasing because the derivative is positive. However, in the context of the problem, you have to be a little bit more specific. So what I would say is, instead of W, I would say the temperature of the water temp is increasing. And now we have to restate the numbers involved. Specifically the time t equals 12 and the answer of 1.0166. So using correct units, so the water temperature is increasing at, and I'm going to say approximately because this was an approximation. If you leave the approximately part out, I believe they would still give you credit. However, this is an approximation, so the water temp is increasing at approximately 1.0166. And for the units, in the numerator, we subtracted degrees Fahrenheit. And in the denominator, we did 15 minus 9, which is minutes. So there is your unit, 1.0166 degrees Fahrenheit per minute at time. And you restate the time as well, t equals 12 minutes. So some crap writing there, but there is your explanation in the context of the problem. Okay, use the data in the table to evaluate, not approximate. So if we're going to evaluate a definite integral, you find the antiderivative, and you evaluate it. So the antiderivative of W prime would be W from 0 to 20, and that would be W of 20 minus W of 0. W of 20 is 71, W of 0 is 55, and that would give you an answer of 16 degrees Fahrenheit. We did subtract, we subtracted temperature in the end. We did 71 minus 55, and those are degrees Fahrenheit. So 71 minus 55 is, 16. For some reason, I'm doubting my math there. Okay, now interpreting the meaning, we ultimately subtracted units of degrees, units of temperature, degrees Fahrenheit. And so the meaning of this, the area under the rate of change tells you the total amount change. And so the total amount change in temperature is 16 degrees Fahrenheit. I would say the temperature, I'm not writing. The temperature of the water increased. And you have to restate all numbers that were involved in the setup. Increase 16 degrees Fahrenheit from T equals 0 to T equals 20 minutes. So there's your explanation for part B. Let's go on to D. So from 0 to 20, the average temperature is written by this integral. Use a Riemann sum with 4 intervals. A left Riemann sum, that's what I was wondering. So a left Riemann sum with the 4 intervals indicated by the table to approximate that. So let's do that first. So 1/20th of 0 to 20 of W of T. Now remember, the Riemann sum does not deal with 1/20th. It only approximates the integral part of this setup. And so the Riemann sum means we're finding the areas of rectangles. The table has inconsistent changes in T. And so we're going to have to treat this as 4 completely separate rectangles, which is kind of how they've been doing it recently for the last 10 to 12 years. So 1/20th of 4, that's the base of my first rectangle. The height is determined by the left side, so the height will be 55, and then 5 times 57.1, 6 from 9 to 15, and the height of 61.8, and then 5 and 67.9. And then this is a calculator problem, so I would punch this in the calculator, and we get an answer of 60.79. And you did not have to do that. The units would be degrees Fahrenheit because we found the average temperature. The reason I would want to do that, this is a calculator problem, and the reason I would go through the hassle of finding that answer is because they tell you, and you should know anyway based on the structure of the integral, that this is the average temperature. So I wanted to punch that in and see if I got an answer that is a reasonable average for these 5 values. Now, it's not the exact average of the 5 values, but it's going to be somewhere in the ballpark, and 60.79 is a reasonable answer, so I like that. Now, the question after that is, does this represent an over or underestimate of the average temperature? And the way we figured that out is you have to think about how we accumulated this area and what this function looks like. And in the very first paragraph, they tell you that the function W is increasing. And so if you have an increasing function, now I don't know exactly what W looks like. I know it's increasing, and I used left endpoint rectangles. If you draw left endpoint rectangles on an increasing function, your rectangles will always be below the curve. So a left endpoint Riemann sum will underestimate the area under an increasing function. And the explaining your reasoning, you just have to mention that the function does increase. So this is an underestimate because W of T is increasing. All right, and then that brings us to the last part. So from 20 to 25, so we are now going beyond the table. The function W that models the temperature of the water is given by this derivative. So they give you a derivative for the functions for the water temperature for 2025. Based on this model, what is the temperature at time T equals 25? So they're asking you for the temperature at 25, and they gave you the rate of change. So this one, W of 25, I know what my temperature was at time 20. So there's a starting point. And then I need to measure the change from 20 to 25. And so we're going to do the net change from 20 to 25 plus the initial condition. We will throw that in the calculator. And I want to make a very specific point here because I graded a problem last year. In 2019, I was an AP reader, and I graded a problem very, very specific, very, very similar to this one, where you had a definite integral. It was a calculator problem, and you should be okay just throwing this in the calculator and getting the final answer, which is, what is my initial temperature? 71. It'd be 72.01, no, it wouldn't. It'd be 73.043. However, if you did that in 2019, you actually lost a point, and this really irritated me. I thought it was very unfair to the students. But one of the points that you got was for actually writing down the value of the definite integral. And this ticked me off, which would be 2.043. This ticked me off because nowhere in the problem did they tell you to actually write down that value. They only asked for the final amount. And so a lot of people skipped that and they lost a point because they didn't write down the value of that integral. So I would encourage you to always write down the intermediate answers rather than throwing them in the calculator, because you never know what kind of weird criteria they're going to come up with for you to get all your points. So please write down this step right here. That is a very important step. They may give you credit for that. They may give you full credit for skipping to the final answer. I don't know. But because we don't know, we sometimes have to guess how they're going to grade the problems, which I don't think is fair. But that's what it is.